Here in this video we are going to discuss about the maximum force and acceleration of a charged particle moving in a magnetic field, and if kinetic energy is given but not velocity is not given. In this case, how do you find the maximum force acting on a charged particle? We know that when a charged particle moves in a magnetic field, the force acting on the charged particle will be Q into V cross B. This is called magnetic Lorentz force. The scalar form is, so when you want to write this, B, the cross product A cross B is AB sine theta. So Q V B sine theta n cap, where n is a vector along the direction perpendicular to both magnetic field and velocity. So the magnitude of the force vector, suppose the only force equal to B Q V will be there and sine theta. So force is maximum when this whole value is maximum. So the maximum value of sine theta is 1. That happens when theta equal to 90 degree. So the maximum force, we have to substitute theta is 90 degree, that is BQV. Since velocity is not given, we are going to write velocity in terms of kinetic energy. So we know kinetic energy K equal to half mv square. Cross multiply 2k equal to mv square. 2k by m equal to v square. When you take square root, you get v equal to root over 2k by m. I am substituting this here for v. So the maximum force acting on the charged particle is bq into 2k by m. So this is the maximum force. And what about the maximum acceleration? We know that F is equal to ma, which means a equal to F by m. A equal to force by mass. So maximum acceleration is maximum force by mass. Maximum force is bq into root over 2k by m divided by m, which means the acceleration maximum equal to bq. I'll try to bring this cube root inside, so let 2k be there. When I'll take one intermediate step, bq into root bq by m into 2k by m. So this m going into the square root, this becomes m cube. So there are two important equations we have got here. One is the maximum force and the other one is maximum acceleration. Here you see maximum force. If the here the kinetic energy is constant in a magnetic field, so the kinetic energy does not change. So the maximum force depends on inversely proportional to square root of mass. So the maximum force acting on the charged particle is inversely proportional to square root of the mass. And here acceleration is square root of m cube. That means maximum acceleration equal to 1 by square root of m cube, which can be written as a max equal to 1 by m power 3 by 2. So the maximum magnetic force acting on a charged particle moving in a magnetic field is inversely proportional to square root of m. Maximum acceleration is inversely proportional to m power 3 by 2. Or this can also be written as maximum acceleration equal to m power minus 3 by 2, and maximum force is proportional to m power minus 1 by 2. These two are very important questions for one word, so practice once.